To find the probability of an event occurring, we're going to find out the number of ways that we can have that happen, what we want to have happen, and divide that by the total possible ways that something could happen. So for example, let's roll a die. So we have a six-sided die right here. I want to know what's the probability of rolling a 5. Well, the favorable outcomes, the outcomes I want in this case, are how many 5s there are on a six-sided die. Well, there's only one 5. The total number of possibilities are 6 different numbers that could come up. So my probability of rolling a 5 is 1 out of 6. Now, probability can be expressed as a fraction, as I just did. It could be expressed as a decimal. So if I divide this out, I get 1.6 repeating, or 0.16 repeating. Or I could express probability as a percentage. So I could say about 16.7 if I round off then percent. So probability can be expressed any of those ways. Probability of rolling a prime number when I roll a six-sided die. Well, I need to figure out first how many prime numbers are there on a die. One's not considered prime, but 2, 3, and 5 are all prime. So there are 3 possible ways to roll a prime number out of 6 possible outcomes altogether for the six-sided die. I always simplify fractions, so the probability of rolling a prime number could be expressed as 1 out of 2, or 0.5, or 50%. Odds are similar to probability. However, rather than expressing odds as what we want to have happen out of a total number of ways things can happen, odds are going to be expressed as how many ways something can happen versus how many ways can it not happen. And there's 2 ways we can do this. Let's start with odds in favor of something. The odds in favor of something is going to be how many ways it can happen compared to how many ways it cannot happen. So for example, I want to find the odds in favor of drawing a 10 out of a standard deck of 52 cards. Well, there are 4 ways to draw a 10. There's 4 10s in a deck. I'm going to usually set up odds as a ratio, so I'm going to compare that to the number of ways I cannot get a 10. Well, if there's 4 10s in a deck of 52 cards, that means there are 48 cards that are not 10s. So again, odds in favor of something happening is how many ways can it happen compared to how many ways can it not happen. And typically we'll stick with a ratio for doing odds. I always simplify ratios, though, the same way I'd simplify a fraction. So my odds in favor of drawing a 10 are 1 to 12. Okay? Odds against something happening is going to be the exact opposite of what we just did. How many ways something cannot happen compared to how many ways it can happen. So the odds against drawing a club. Well, I want to first figure out then how many ways I cannot draw a club. Since there's 13 in a deck, that means there are 39 cards that are not clubs, compared to what we just said, 13 cards that are a club. So my odds against drawing a club are 3 to 1. Meaning I have a more likely chance not to get a club than I do, which makes sense. There's more not clubs than clubs in a deck. Compare all this to probability, where I express something against a total. So, for example, the probability, again, of drawing a face card, I want to know how many face cards there are in a deck. Well, there's 12, the jacks, kings, and queens, and I compare that to the total number of cards in the deck, so 52. So there's the big difference between odds and probability. Probability uses a total, where odds uses for or against, how many you have or how many you don't have. Simplifying that gets me 3 to 13, which I could express as a ratio, or a fraction, or a decimal, or a percentage, which would come out to be about 23%. But odds typically are going to stick with just a ratio.